Hello, everyone. I'm Jasmine Henry. Welcome and thank you for coming to our 3 p.m. PST session titled A Case Against Google, A Case Against Google IT, a Cognitive Science Approach. I have a few quick housekeeping announcements. I'd like to thank our Diamond, Platinum, and Gold sponsors who teamed up to help the Diana Initiative put on an accessible event. So I would like to say thank you to MongoDB, Microsoft, Verizon, Salesforce, Amazon Information Security, eLearn Security, Intel, and Remediant. We will be wrapping up around 3:50 PST today, but please join us for our closing keynote and networking at 4 p.m. on stage 1. Today's session is live and it's recorded. There will be about 10 minutes for questions at the end, so please use the chat to ask almost anything within reason. Thank you again, and please join me in welcoming our speaker, Duane Dunston.
Thank you, Jasmine. So I'm an associate professor at Champlain College, and I've been involved in cybersecurity since '97, and that was in the education and the government sector. And in the government sector is where I got my primary security experience, building the cybersecurity program for the agency, and also traveling around to different agencies and helping them with their security and teaching web application security courses. And also, last 6 years of my career in the government, I was on the incident response team. And I recommend if anyone can get involved in the incident response team, it is a really great experience. I've been teaching since 2006, primarily online. And then in 2012 is when I joined Champlain College and have been teaching in the classroom since then. I'm also a candidate for my doctorate of education degree at Northeastern University, and I'm focusing on cognition and learning. Why not just Google it? One is because information overload. In this presentation, I'm going to have my fictitious system administrator who's transitioning to cybersecurity. And if I tell my mentee to just Google it, then there's an information overload problem. Because when you type a Google search and you don't use any of the advanced operators, you get a lot of results. And as a result, they can overwhelm them with what they may be reading. And I'm not undermining Stack Overflow. I use it as a resource for helping with solutions to problems. It's just that the explanations of the solution can be very technical, and it may be, my mentee may not be able to understand what they're talking about as a result. And you probably heard someone ask, or maybe you even made the comment, I don't know what question to ask, especially at the end of a presentation where so much new information was provided to you that you don't know where to even start asking questions. So even though people may have many years of experience in the field or with the topic, people still have trouble asking questions when they encounter new information or new situations. So learning how to ask open and closed-ended questions is a very valuable skill that I'm going to help with my mentee learn how to do. And the question formula technique is a really good step-by-step process to teach people how to ask an open-ended question so they can get a more detailed response to what they're asking, or either a closed-ended question where they're going to get a one-word or a very short response to the question they're asking. But the question formula technique is very powerful and can help with navigating and learning how to search for information. The two theories I'm going to be working with to explain this case against telling someone to Google it is the cognitive apprenticeships. And this is the same as a traditional apprenticeship, but it just adds a cognitive framework to optimize the learning for both the mentor, but mostly for the mentee as well. And those phases that are most important here are the modeling, scaffolding, fading, and coaching, which I'll be discussing as we go through the presentation here. And also cognitive load theory to help explain how we learn and what impacts there are to us learning. This concept of working memory is important because that is a temporary storage space for information. So when you're learning something new, that information is put in working memory, and the goal is to get it into long-term memory. Otherwise, you probably wouldn't be at that presentation like this one. And that long-term memory is where you're developing schemas or your existing knowledge, things that you can start to learn new information from those existing schemas. And some impacts to working memory based on cognitive load theory is the intrinsic load. That is our inherent belief in the difficulty of learning a new topic, or the difficulty of learning a new topic. If I wanted to jump into learning quantum physics, it'd be very difficult for me to jump right into doing that because I don't have that background knowledge in mathematics to do it. The extraneous load is where cognitive load theory spends the most amount of time. The extraneous load is really how information is being presented to someone to learn. So if the information is presented properly, that working memory space is held, the information is held in working memory, and it's very quickly transferred into long-term memory. And that process, those mental activities, those mental and cognitive processes that transfers the information to long-term memory is a germane load. And this can be impacted based on our motivation to learn. So it's important that when you go to training or send someone to training, like your employees, or in this case, my mentee, if they really want to transition into cybersecurity, it's highly likely they'll have the motivation to want to learn it. But if you send someone to training who don't want to learn it, or it's not applicable to their career, more than likely, they're probably not going to remember much. And it's because that germane load didn't transfer information from the working memory into long-term memory. And an example of how this can happen is the use of acronyms and initialisms. So when I first started learning about cybersecurity, a lot of people and sites used a lot of acronyms that I wasn't familiar with. So it was hard for me to follow because they kept using these acronyms like CERT, for example, or initialisms like APT as well. They didn't have APT then, that term then, when I started, but like CIA. I'm thinking Central Intelligence Agency. But it's the mere fact that someone is using these acronyms and initialisms for someone new who doesn't understand what they mean, they lose interest in what's being told. So that information, or most of it, is not committed to long-term memory. So how do we learn? In cognitive load theory, there's a lot of principles and effects, and I'll try to point those out as I'm talking. The borrowing and reorganizing principle is that we have learned most of what we know and do based on learning from other people, either being told, reading, etc. And as we start to learn more, as we become older and more knowledgeable in a topic or a skill, we start to reorganize those things that we learned because they may not have been correct for one thing, or we just improve on them. Because of that existing schema that we have, we're able to build off of that and learn more. We also learn by being creative. Once we reach the end of our knowledge, we start to make use of all these things that we know to do and not to do in order to come to some solution or solve a problem. My door don't open, I'm not going to take 5 steps back and try to break down my door. I'm going to check the lock. I'm going to, see if there's some kind of blockage, for example. So I'm going to get creative in how I figure out how to open that door. Learn by example, like I just gave, trying to explain what creativity means with cognitive load theory, or with human cognition, excuse me. We learn by example. You hear a lot of people say, if I do it, I'll remember it. Well, that's how we've learned. We learn how to walk, talk, and recognize things by repetition, by learning by example. People telling us, or people showing us how to do things. Or people say, I'm a visual learner. This is what this concept is of learning by example. You're able to see someone perform a task, so it becomes much easier for us. And when information is applicable to the real world or to us personally, we tend to want to remember, and we tend to remember the information because we're actively engaged in it. And by having this existing knowledge or these schemas, we're able to work off of those existing examples in order to existing knowledge to build new knowledge. And I'll talk about that with our mentee here. So my mentee is a Windows system administrator, 15 years of experience, and they want to transition into cybersecurity. And they have some basic knowledge with networking, even though they don't do that on a full-time basis because they went through the CCNA, the Cisco Certified Network Administrator program. You see how I just explained what CCNA is. AD is Active Directory, a system to manage multiple Windows systems in an organization. So they want to transition into cybersecurity and learn Linux. So let's see how we can do that and help them learn this. So with this cognitive apprenticeship approach, that first step is modeling. But before I get into that, when you're working with a mentee, the most important thing you can do is build a relationship with them. If there's no relationship there, it's going to be a very difficult learning experience for all people involved, whether it's one person or a group of people. We also want to learn about their experience. I know my mentee has this experience because of the expert reversal effect. And what that means in cognitive load theory is that they already have existing knowledge and schemas on Windows administration. So I don't need to reteach them Windows administration. I don't need to teach them how to set up Active Directory. They already know that. And what can happen with the expert reversal effect is I'm undoing those years of schemas that they've developed, which can be detrimental to learning because they're having to relearn stuff my way, if you will. And you don't want to do that. It also reduces the amount of time to spend with the mentee because you can jump right into new information. Worked examples was probably, I think, the first concept in cognitive load theory, and that's what learning by doing. My system admin, my mentee, wants to learn cybersecurity. So I'm going to show them how we do things on Linux and how do we secure systems. So let's start with this example of creating a new user, for instance. What I'm going to do here is I'm going to teach my system admin how to create a new user. And I'm not just going to type out this command and show them how to do it. I'm going to explain what this means, but in a context that they understand. For example, this -k etc scale, what I'm going to ask my system admin is when a new user is created, what directory on Windows is copied into their profile? And they're going to say the user profile. And that way you can put any folders or any files that the user needs in their default profile. Well, this etc scale, that's the same thing. So you see that system admin is using their existing schema. I'm going to create a new user. They need a default profile. On Windows, it's one thing. On Linux, it's something else. So now they're focused on this new concept, not this big thing called Linux, if you will. I'm going to make a directory, and I want to specify the directory to be /home/Duane. This home is what's a newer concept to a system admin. And you can explain this by stating that this home, you can ask the question, what is the default home parent directory for Windows? And they say C:users, Windows 10, for example. Well, you can equate that to /home on Linux. Once again, existing schema, C:users to /home, and that helps build that concept so they can commit that to long-term memory pretty quickly, because that working memory of this new home is quickly transferred because we're focused on something. We help them reduce anxiety by asking them things that they already know, and equate that to, give an example of what that means, in this case, /home. And this bin bash, this is the shell for my user. And this bin bash may be, again, a new concept that may be confusing. And so you ask them, have they ever used the command prompt? They say yes. We'll say, well, this is the command prompt for Linux. So once again, we're building schemas here. We're using existing knowledge, the schema, to introduce new knowledge. And then we change permissions to chmod 700. Now, in this case, I'm using the command line to do this. And I can ask the admin, how do they change permissions with the user? And they explain the process. You right-click, click properties, and then you set the permissions. Well, on Linux, we do it this way with the chmod command. The command line can be very intimidating for some people, and it can be very difficult to learn. So instead of forcing my mentee to learn it, I could also use webmin, which provides a GUI, something they're used to when it comes to administering a Windows system. Even though PowerShell is very powerful and also used more often, they may not use PowerShell on a regular basis. So I'm going to help reduce that workload on them, on their working memory load, by teaching them how to use webmin instead, so they get a GUI to manage users and create this information. I'll create the permissions, but I'm still going to use that same examples to explain how home is equivalent to C: users. But what's important with people and their learning is providing reflections. So once I show them how to create a user account and explain these things, I'm going to ask them to explain to me what we just did. Instead of typical lectures that go for an hour before there's questions, things of that nature, or you may not get to ask questions at all. And so you're stuck there after 20 minutes. Between 20 minutes and the end of the lecture, most of the information is gone, unless something really funny happens in the middle of that lecture, like, I don't know, an elephant walks in a room. You're probably not going to forget that, but you'll probably forget after 20 minutes. That's a magic number, because after 20 minutes of new information, we tend to forget most of it because that working memory capacity is very limited. And if we're having a hard time understanding these foundational principles in that first 20 minutes, it's doubtful we're going to remember or learn much else after that. Which is why we tend to remember the beginning and end when they say in conclusion. So reflections are essential. You want to reflect often, and I want to have my mentee reflect often on what they learn, because you're also teaching them how to learn. And mentors, it's okay to not know. Let your mentors know what you do know and what you don't know, because it's infectious. Then they'll start to do the same thing, because they look at you as if you are all-knowing, and you have to let them know you're not. But what you can do is demonstrate to them how you learn. In this case, this is how I Google. They ask me a question, I don't know the answer to it. I'm going to show them how to Google, because if they learn these advanced Google operators such as cite: then they learn how to restrict their results, so they get limited results. This issue of redundancy effect, we tend to think that if we give someone like 4 or 5 URLs to learn something, that's going to be helpful for them. Well, the literature shows it's actually detrimental to learning, because one, those websites may not have cognition in mind as they're writing that tutorial. So my mentee has to look at 5 different sites, 5 different explanations, and then synthesize all that information. And that could impose a heavy load trying to figure out what all of these 5 different explanations mean. So I'm going to show them how to perform my Google search, and I'm going to point them to some reputable sites, so they know if I have a question, I can go to this site, more than likely because it's going to give me some very good information, and it's going to explain it to me very easily as well. Another thing you can do in this modeling phase is have your mentee, I'm going to have my mentee document what they're learning. That command we just used for user add, they're not just going to add that command, but have them explain in that writing what that command means, or create a blog. And it can be private or it can be public. It doesn't matter. The important thing is that you're having them write, because it reinforces their learning. They have to go back and reflect on that. It gives them time to document it. I'm going to read it and be sure that their technical explanation is accurate, so I can help fill in those gaps of knowledge. And it helps to improve and develop technical writing skills, which it is badly needed in our industry. The scaffolding phase is when we take existing information, in this case, creating a user account and setting permissions, and now we're going to build off of that knowledge. And we're going to show them how to set the password policy. But the first thing I'm going to do is have my mentee engage in metacognition. Metacognition is when we think about how we're learning, how we're processing information, how we think about solving a problem. So I'm going to have them talk out. When you change the policy on Windows, what process did you go through? What tools did you use? Again, helping them remember, we're just going to change our password. We're just doing it in a different environment. So that once they realize, oh, I'm just creating a password policy, just like I do in Windows. And guess what? They only have 2 things to learn now. Because sometimes we're presented with a problem and we get so overwhelmed by, oh man, this is Linux. I don't know Linux. I don't know these commands. I don't know how to do this. Stop, pause. What do you know? Okay, I know how to set password policies. This is why we set password policies. This is what these password policies mean. They mean the same thing on Windows that they do on Linux. So once again, I'm reducing that cognitive load, that intrinsic load of them thinking is difficult, and letting them focus on two new learning pieces of new information. This change, which shows you the, or in this case, -L, will list the password policies for the user, Duane. And then I'm going to teach my mentee that that password policy comes from this file, login.defs. And if I change these three settings, it's going to update the policy for this user. So I've helped my mentee learn or reflect on what they already know, and then focus on running two new things. That's it. The change command and modifying the login.defs file. I don't have to explain to them why we need to change password policies. I don't need to explain to them what maximum days mean or the minimum days of warn age. They already know that. The expert reversal effect, remember that? This randomness as Genesis principle is a fancy way to say creativity, because in the scaffolding stage, we may be presented with problems that we are not sure how to solve. So we start becoming creative, either as mentors or for the mentee, giving them things that they want to solve. And this knowledge transfer that we engage in is the most cognitively intense process we can be involved in. Knowledge transfer and creation of knowledge. This vertical transfer means we're going to take existing information I just learned and apply it to something similar. In this case, the netstack command on Windows and Linux perform the same task, show open network sockets. dir and ls perform the same task, list files in the given folder, and then adding routes. I don't have to explain to my admin what routes are, why they need to add routes. They already got that background knowledge because I talked to them, I learned that. So all I need to do is focus on teaching them a new thing, one command, how to add a route. So I'm telling you this about dir versus ls. Dir lists details about the file size, and we tend to do this right here when we're talking to somebody. It lists the output, permissions, etc. That's the imagination effect problem. When we're trying to teach something new to someone and they can't conceptualize what we're talking about, that's why someone says, can you draw that out for me? Can you create a diagram? Because we're making use of our, in this case, division. Or if someone prefers to hear it, then they can learn that way as well. So what I can do is simply show them with a worked example. Here's the dir command. They're familiar with this. They're a Windows admin. They know about timestamps and file sizes. I don't have to explain that. All I'm going to do is show them how it looks on Linux. If you type ls, you're just going to get a list of files. But if you type ls-l, then you're going to get a long listing, very similar output as Windows. What I'm going to do is ask the admin, where's the date and time? Where is the user that owns these files? Where's the file name? What's the file size? They may not be able to point it out, so I'm going to say right here, that's the file size. Timestamp, they should get that. And then the file name, I shouldn't say should, but I'm assuming they can figure that out. But what is this right here? This is new. This is not in this output. So you see, my admin is now focused on, my mentee is focused on one piece of new information. What is this right here? These are the permissions. User, group, next 3 bits. The last 3 bits is the world, other, anybody on the system. They already know about permissions. I don't have to explain all that. I need to explain what this little dash means right here. If it's a dash, it's a file. If it's a directory, it's a D right there, for example. So I just took a new command, ls, and I asked them to explain to me what the stuff is that they already know. The date, file name, maybe file size. These are all the same size. But I have to explain just something new, just one piece of new information to them, or maybe 2, this first bit here. And then there's horizontal knowledge transfer, which is much more complex and difficult to do. In this case, I'm going to have my admin configure file shares on Samba, which by itself can be intimidating because there's no GUI really, unless you have a third-party tool. But for the most part, it's going to be via a text file, and they're used to doing this via a GUI on Windows. So I'm going to ask the question, what security settings do you implement to protect file shares in the Windows domain? And they're going to list out these different things that they do. Forget about Linux, forget about Samba. Just what do you normally do on Windows? And I say, okay, you hide file shares, right? Okay, I've shown you how to do Google searches. I've shown you how I think about solving problems and how I think about my question. What question are you going to type into Google? Remember that modeling we did before? Now with scaffolding, we're going to ask them how to do it. We're going to have them reflect on it. And they're going to tell me they're going to search for this or that. I'm going to say, well, you may not want to search for that because of this. Give them some examples or explain why what they stated may not be the optimal search criteria. And then I'm going to have them do the search, and then I'm going to start asking them questions about the site and then the version of SAMA that they found, and also the configuration setting. So I'm helping my admin, my mentee, learn how to learn, having them think about what they're trying to do, think about what they already know, and then start working on what they don't know. Kind of work on reducing the amount of workload, amount of information in their working memory. Keep that on things they don't know. And then the guidance fading effect. This is the hard one. Guidance fading means, as a mentor, I'm going to start pulling away this hand holding, if you will. I'm going to start providing so much guidance on how to perform certain tasks. But what I am going to do is I'm going to just hear how they're thinking about the problem, seeing how they're thinking about what they know, what they don't know, and then how they're going to work on solving this problem. In this case, how they're going to secure IIS. And I'm hoping my mentee has learned, okay, what do I know about IIS? What do I know how to secure on IIS? Okay, let me tackle this one thing first. And then they can focus just on Apache Web Server. So the problem becomes much narrower the more they reflect on it, the more they think about what they already know, what they don't know. But it's hard. You have to know your mentee. You have to work with them. You have to engage with them to understand how they're learning and what they're learning and what their struggles are. So you have to pay attention in this phase in order to get to the phase of coaching. And with coaching, you're pretty much stepping away. My mentee now is transitioned from system admin and now a security administrator. And so they still reach out to me when they have questions about things, but for the most part, they are almost autonomous. Kind of like coaching can be seen like a sport. The coach is on the sideline yelling out, no, stand over there, get your hands up. And all they're doing is reminding them about the fundamentals. They're not telling them, no, okay, hold your hands out like this. They're gonna throw the ball to you. Now I want you to catch the ball. Now dribble the ball or throw the ball. They're not gonna do all that. That's fundamental stuff. That's things that you should already know. They're gonna remind you of those fundamentals so that you can get back into the game, so you can focus. Same thing here with our mentee. They have to secure SIMmail and add TLS. Well, what do you use TLS for? Do you use it for, we've done this on a web server, so you need to do what with that communication channel? Oh, yeah, just secure the communication channel. All right, what is the SendMail server? Oh yeah, we did configure a SendMail server. So we're taking a problem and we're breaking it into smaller pieces. What do you know? What don't you know? And now, how are you going to solve this? What are you going to do? And in this case, let's say Google there's no tutorial on how to do this. That's when you have to start getting creative or reading the documentation. And once again, technical writing is not a skill that many manuals are really good at. So they may have to start playing around with things on their own. But the mere fact that they're doing things on their own without asking you mean that you did a really good job with modeling, scaffolding, and you started fading properly with that cognitive apprenticeship. So this coaching, you're really on the sidelines and just reminding them of the fundamentals. You don't tell them how to solve the problem until you see, okay, they've exhausted their knowledge. Let me see if I can help them now. That's when the coach jumps in. But the coach never gets into the game though. So this is the A framework that you can use for mentoring. And I hope I've explained why telling someone to Google is not helpful. I've said it in the past. I admit that. The more I learned about cognition and learning as a result of my doctoral studies, the more I realized how that doesn't help. Because once again, they may come across tutorials that don't explain very well what it is they're looking for, because they're struggling with the question. Google it. Google what? My question is this: I don't even know where to start with that. I don't know what to ask. So that's why we need to work with our mentee on learning how to ask questions. And you as a mentor, you can go to this website or purchase that book on how to ask questions. So you can work with your employees, work with your mentors, and your other mentees. It's a really, really great formula. In one of my classes, I used this question formula technique, and that became the quiz. Their questions became the quiz over the course of the semester. What I didn't cover in class, they found out on their own. So our system admin has transitioned to cybersecurity on the Windows and Linux. We've established a relationship, hopefully a lifelong relationship, and we reach out to each other. And the sort of the epitome of the mentor-mentee relationship is when the mentee can start to assist and help the mentor when they get stuck. That's when you know you've done a really, really good job with that. Or the system admin may realize, I don't want to do cybersecurity, but you taught them some very valuable things. One is how to learn in this process. One is how to ask questions. One is how to know that you know what you don't know as well. You help to improve their technical writing skills, which is, again, is essential. You're improving your own social skills. You're helping them develop social skills, because it's hope that the way they were nurtured and taught to learn transfers. Many of us learn on our own. I learned cybersecurity mostly on my own. I got a few SANS courses back in '97 when they first started. I don't know how long they've been out by then, but they had like 3 or 4 free courses, and I went through those, and then most of what I learned has been online. And because my undergraduate degree is in sociology and my graduate degree is in management. So even though I learned on my own, I don't treat people the way I learn. I don't say, well, I figured it out, you go figure it out. And there's a lot of that we see on the internet as well. So we want to help guide people. We want to be patient with people. We don't want to tell someone just Google it, because once again, that's not very helpful for their learning. We want to remember how people learn. When you go to boot camps, you may be sitting there for 6 to 7 hours just being pumped with the information, just to get through that week of all the stuff they have to get through, and you may not learn anything. And just because you are in a boot camp and you're typing things all day long, there's no guarantee you're going to remember all that either, because it's a lot of new information all in one day. So what these boot camps should be doing is providing reflections. At the end of this lesson, okay, write down what you learned. Write down what's still confusing to you. So at least you've got that documented, and you can go back at a later time and work on that. Or have a 30-minute Q&A, because there's more than likely someone else at that boot camp who has the same question as you do. And the same thing with writing with your blogs. You have to consider your audience. If this is a new a website for people new to cybersecurity, you have to write for someone who's new to cybersecurity. You have to refrain from using so many initialisms and acronyms, or just spell them out, explain what they mean, and then use them, or provide a hyperlink to a glossary of terms, because they may get stuck on that one term, not knowing what all the other stuff means, because they can't figure out what that APT means. How does that apply to everything else you just said? So we want to minimize the amount of information in working memory. We want to maximize that germane, or minimize the germane load, so they can put information into their long-term memory. And the same thing applies to recall. We need to provide instructions so people can recall information. And we do that with metacognition, getting people to stop and think about the problem. What do they know? What don't they know? When I have big assignments in my classes, I created this metacognitive survey, because I don't know what else to call it. And the first question is, what is this assignment asking you to do in your own words? The reason for that is many times students will submit assignments and we're like, why do they submit this? So I stopped asking that question and I start asking them the question in your own words. What are you trying to accomplish? And then What do you currently know how to do for this assignment? And then what don't you know? And I take time at the end of class to review their um, their feedback from those 3 questions, and I can help address those gaps in knowledge. Or I can say, oh, remember we talked about these things here, or refer back to these things here, or what definitions, or if I see definitions and things like that, I can go over those right in class right away. So at the end of my classes, I provide that time to reflect on what they learned. And when I say, are there any questions? I actually pause and wait for questions. Just like I did just now, there's actual silence so they can think about what they've been learning and have time to think about or reflect on that. So that's the end of my presentation, and I'm happy to take any questions now. Now, chat event, there we go. No, stage. Okay, I don't know where to start with questions. Let's see. Let's go to the very top. See, I don't know where to start. I didn't know what question to ask. Zena, I love that. You're welcome, folks. I appreciate you all being here. Yeah, boot camps. I've been to boot camps, and even in a day, I'm like, oh. And especially with the expert reversal, where you have people who are very knowledgeable, and they spend 2 days talking about these basic things. When I say basic things that they already know, those 2 days can be used with newer information to maximize on their learning experience. Oh, Brooke, that's great to hear. Yes, I will make the slides available. I'm going to provide a link on my on the description page for this talk. Remembering acronyms, the best way I found to do that is really to have your mentee, when they're talking or explaining things, have them use those acronyms. Have them use the terminology and the terms that you're having them learn and that you use. And also in their documentation, have them write that out as well. And just, so the more repetition there is, the more likely they're going to remember it and use it more often. Jane, I'm not, but I appreciate that tip. That's something I should look into for sure. Yeah, there's a website, I think. Let me Google that for you or something like that. And actually, that's a good learning thing, because now with e-mentoring, we need to make use of tech resources, and something that's and a part of the training process is to say, I'm not sure, but this is how I would search for that. And I would also recommend learning some of these advanced search operators like site:, and then teach them how to use that to narrow down their search results. So when you tell them about a reputable site, they can search, they can type in the search terms site:, that reputable site. So they get just the information from a reputable source. Absolutely. Scaffolding for mentees and new hires. Yeah, scaffolding. That goes that as I was explaining before, when you have someone reflect on their own knowledge, their own learning, what they already know, and it helps to relax them, because many people go into a new job with imposter syndrome. And I have no literature on this by all means, but I do believe that when people have time to reflect on their own knowledge in a new job, it helps them realize how much they do know. And then it helps put them at ease about what they need to learn. Because, like an example of the, you know, adding file shares, they already know about file shares. They already know about security features that you need to add to a file share. They just don't know how to do it on Linux or with Samba. And so they can focus on what they don't know and realize how much they actually do know. So finding ways to allow them to reflect on the existing knowledge, preferably privately, so they can, that they're not, that imposter syndrome is not like out in front of other people, I think is one good way to help with that scaffolding theory, help with scaffolding. And, you know, this is something I haven't done in a corporate before, which is interesting, is to have some type of, that's a good question. Now, Jasmine, that's a good question. This may become my doctoral research, my dissertation, which should start next fall, of applying scaffolding in corporate settings. I like that. So I'm not sure how to respond to that right offhand, except for those strategies I just mentioned. Thank you, Sakura. I love that name. That's cool. Thanks, Brooke. Oh, yes. Horizontal knowledge transfer is when you learn information, for example, like learning about file shares. On Windows, it's pretty easy. Let me rephrase that. On Windows, it can be relatively easy because you have a GUI. And if you've been doing it for a very long time, then you can set up a new domain in another organization and set up file shares pretty easily. However, if you go into an organization and they're a Linux shop, excuse me, or Unix shop, more than likely they're going to be using Samba. And even though they're setting up file shares, they're setting up file shares using a very different technology, a very different software program in a very different way. So they're having to take what they currently know about file shares and then learn how to apply that in using a different software program. Or if the organization is using Samba for their domain controller, then things work quite a bit differently, different configuration settings than they do in the Windows environment. Or if you are an attorney, you may know a lot about law. If you're a patent attorney, but if you want to go into criminal law, then that knowledge transfer is much more difficult. It's a different type of law that you have to apply your knowledge to. You got the background legal framework, but now you have to learn a different legal procedures for criminal law. I hope that helped, Bailey. Mary, that's fantastic. John Sweller, he's the originator of the cognitive load theory, and I should have typed up some of these names. Paul Kirshner, he's on Twitter, and he is another cognitive load theorist as well. And they have a book on cognitive load theory. I'll create a references slide, and I'll put that at the end of my presentation. And when I post that, you'll be able to see these references. Thanks, folks. Oh, cool, Zena. That's great to hear. And I'm happy to speak with folks as well. I don't, this is kind of what I do. Yeah, uh, drawing from life experiences. The reason I'm laughing about that is because I just finished a literature review on adult learning and adult learning theories, which I am not a fan of adult learning theories because there's no adult learning theory that doesn't apply to children as well. Some adult learning theories apply to preschoolers. So one of the central tenets of adult learning is that their life experiences can helps them learn differently than children do. I'm not found in evidence to really fully support that to be not so much universal but consistent. Um, that requires that relationship building with your mentee to find out about that person, where they come from, how they learn, what schools they attended, how they do in school, what they struggle with in school. So you really have to sit down and talk with them for them to be able to, for you to be able to help them, for you to be able to use their life experiences to help them with their learning and create connections. Because you can say, oh, remember when you said you were 12 and you did this? Well, this is very similar. This is how you can help make those connections by making it personal, even more engaging for someone. But that's all part of that relationship building. There's a research article that's based on two ladies who they were academians that moved into academic administration, and their research, I think, is called Wine and Wine, something like that, where they met over wine once a month to whine about other things, what they were experiencing. And they were essentially using their own experiences to teach each other. So the mentoring was more of a emerging mentor. There was not one person mentoring the other. It was a totally mutual relationship there. So the only way you can use your mentee's life experiences is to get to know them. Yeah, again, once you get to know the person, then you can probably use analogies that apply to their life, or you can use case studies. So that's why it's good for mentors. We need to keep reading cybersecurity stories so we can take that knowledge and apply it to something practical. Because if you go to training that's not applicable to your career or to the work you do or your personal interests, it's really of no value to the organization to send you there. But if you can find some meaningful training that applies to your work, applies to you personally, it's more likely to stick. Or if you can find examples of how it applies to something in your industry. So if you're in the legal field and you hear about a breach in the finance field, you hear it, but you don't really hear it. But if you hear about a breach at a law firm, it resonates more with you. So reading and case studies can help with that lack of having direct experience or knowledge or direct experience with that learning. Yes, we learn all the time, and mentees can help because mentees, when people are new, they ask really, really good questions, things we may not have even thought about before. My good buddy is a chemistry professor, and I'm like, so what is it? Why does that chemical do that? He's like, I don't know. Okay. Skill. Maybe that's intrinsic. How do we deal with objection? I guess the question is, how do we deal with people who are already existing? One is that again, an expert reversal. When people are already familiar with it, with something, then we can send them, or we can. That's a hard question to answer in a minute. I'll put something in my slide about this question here. Hope I don't forget this. I'm going to copy it and paste it into my notepad. I'll so I can put that into my slides. I can follow my next endeavor, Twitter. My Twitter handle is Twitter. Thanks for the follow. Okay. If I missed anybody's question, I'm sorry. I tried to go back as far as I could. All right. Well, thanks, folks.